sets himself up about optimal distance, which is about eye level of this higher bar here. You wave until it starts to track your hand, it recognizes that gesture, and then you have kind of a joystick control of your system. You can move it up, and as you can see in this right hand screen, this box will actually move alongside with you. You can move right as well as down and left. Those are your basic operations here. It's kind of a little trickier to see, but up in that top left hand corner of the screen I'm actually in right now, it has a coordinate system as well as the function it's performing, either moving right, up, down, or left. Now if you want to send these coordinates to the robot, what you're going to do is you just go into this upper right hand corner and it follows it. Now the next operation you can do is if you go into this upper left hand corner, you'll see that the square turned green. Now when you send it that system, it'll actually run in to the machine and the Z-axis will deploy downwards to grab. I unfortunately missed that time. However, and then once you turn it back to red and send it another set of coordinates, it'll reset the gantry arm so that it can attempt to pick up again. As you can see, what we're trying to grab is this piece of metal here in the environment, which that time it did. And then you can move it. As long as it's still green, it'll carry it wherever you want it to go. And then once you turn it red and end up actually sending it that coordinate, it will release it. It will move and release. The final step is actually this reset here, which is this bottom corner, where it'll go back to 0, 0. And that's the basic operation using the Kinect controller for our gantry arm or Cartesian robot.
There we go. I stole it! Steal it back.
So if you put it in here, it toggles it back and forth from red and green. So what you can do is you just toggle it back and right at the... You got it.
Okay.
Oh, alright. So it's kind of hard to see those little purple dots up there. That says 0, 0.
Oh, yeah.
And when you move it up, it says moving up to there.
Oh, that's cool.
But yeah, it has it all up there. And just to prove to you, it won't go further than the top. Can't move further.
Cool.
Same that way too. Here, I'll drop it up closer to the right hand corner. Like I said, I can get it to move a little bit faster too.
No, this looks good.
Oh.
Okay.
Oh,
There you go. So now it's going to reset to 0.
And I can reset on mine too.
And then it'll go back and it'll pick up the.
Oh, that's right. It's gonna go pick up where
It'll go back and pick up the object again.
Oh, you know what? It might actually just reset again though, because I just did a reset.
So if you send a reset, it'll do this. It'll queue it up and it should go back to 0.
And then I'll drop it.
Yep.
Nice. After a strenuous year, we have finally come up with our design here. It is the Kinect controller operating a Cartesian robot. Operates in XYZ. Our design initially started to help either disabled people or people who are unable to actually access physical elements in a given environment. And what we did was we made the interface much easier than using a joystick by having it visual interface. And that's where the Xbox 360 Kinect comes in. However, our robot was designed kind of as a gantry arm from Yaffe's graveyard, which he calls a workshop. It's a little bit of a Frankenstein mixed and matched of pieces. But anyways, we'll get to the actual demonstration.
So Maverick, I was wondering if you could give us a little more detail with the text in the upper left corner.
Well, the text in the upper left corner, it not only sends the coordinates of the position the arm should be in, at least in our virtual display, but it'll send the function it's performing. As you can see, when you move to the left, it'll say moving left, or if it's already as far as left as it can possibly be, it'll say cannot move further left. So it also shows the restrictions there. Moving right, moving down, and moving up, as well as sending coordinates when you're in the top right hand corner. It'll say toggling Z-axis when you're in the top left hand corner, and when you're in the bottom left hand corner, it actually doesn't say anything, it's just a reset though.
And you got a screen over here. What is this one doing?
So this new screen is actually where we can manually send it coordinates. Now this is going to overlook our virtual display and our Kinect controlled operation. We want to enter it in as a ZXY. It'll actually move over to 500, 500. Now since it's a 0 for the Z command, it's going to not toggle the Z axis to pick it up. 300 and 1,200. And it actually picked it up. So something that you can see here, it does say that there are 60 seconds remaining before the electromagnet times out. We set the electromagnet to automatically drop what it has after the time frame if it's being unused. Yeah, you can also type a help command if you want to see what you can actually perform with it. It shows the given ranges. As you can see, Z it's either toggled or disabled. The X goes from 0 to 1,360, and the Y-axis goes from 0 to 2,570. Kind of states that right here as well.
And those are the steps on the stepper motor. If you notice, the Y-axis is actually bigger, even though it's shorter on here on the robot system.
And that right there was just the electromagnet disengaging by a timeout. We also have other commands such as calibrate. So you type that in, which will resend it back to 0, 0 or the origin. We have the command get coordinates. The next one we can do is beep. And as you can hear, there is a beep. We got flash, which will flash the LED in the back. Her display is a little hidden right now. We have board. There you go. And EMH. And we have EE. So when we interrupted the Easter egg, which was the Tetris song, we touched this joystick here in the back. Now this joystick is kind of a manual override as well, so it's not going to be displayed here on our Kinect interface, but you can actually move it in the directions pretty simply by just using that push it in, it picks it up. Kind of same method of operation. It's either toggled on or off. And basic operation. Next thing to note that I kind of want to point out is that we did develop a set of limits that we can send it to. And I don't know if you can zoom in right now, but we do actually have limiting switches on all of these. Okay, which the limiting switch, as you can see, is actually right here. And once toggled, you can see that it scoots back and doesn't allow any further movement upwards.
So if you push it manually to the limit, it'll automatically pull itself back because it hits a limit. Or these limit switches here. So if you pushed it into, say if you pushed it into the limit, and it would tell you the status on the display over there.
Okay, cool.
Also that it hit the limit.
And action.
Moving the arm with the joystick control as well, again. Right now we'd actually like to demo our emergency stop in case your finger was getting pinched or in case it was moving in a direction you didn't want it to. It'll kill it right where it's at, and then once reinitiated, it'll go back to the origin, recalibrate, and then it'll go back out and resume where you left off. Our Z-axis was actually toggled, so it's actually going to go pick it up, and again resume control right where it left off.
And cut.
Welcome to Yaffe's garage, or basement.
So this is the, let's see, is it powerful enough to lift it against the, oh here we go, it's pretty heavy. Let's see. So there's a feature on here that can actually, it's called locked rotor, and it will lock the rotor in place so that it doesn't fall, so that like you can freely move this. Basically the locked rotor position would keep it from moving, so if you had this tipped vertically, it would prevent it from falling. we didn't need that because we're not doing a vertical fall, but basically it's out of calibration, so I'm going to push it until it hits the end, or one of the ends, and we'll reset, calibrating it to the end, we'll reset it, so now it's back in sync with the rest of the system. There's multiple speeds, so there's and also there's the you can activate the Easter egg by being by doing it this way. So you can hold the limit switch over here. And that's that. And you can still, like without, because the Kinect is connected to the socket, it will automatically resume whatever it wanted to do. So you can still control this while you're doing all this too. The cool feature about this too is with the network socket, like we were just demonstrating, you can do all of these things, and you can use the joystick, and you can type things here. You can control this from anywhere in the world, because it is connected to a network socket that is listening on a certain port, and if you have the IP address in the port, you can log into it and send it commands. Okay, so we can do this command, right? And then we can use the joystick to also send a command, or we can send a command from over here to from the computer. And of course, if you hit that, it'll stop. It'll tell you on here. But what's interesting about this is the way that the network socket is set up is that anybody can join from anywhere in the world if they have the IP address and the port number of this.
So our problem statement pretty much states the reason why we kind of came up with this project was we wanted to create a robot for Yaffe and visual component for Maverick. And so we came up with this project where we use the Kinect to visually give commands on the Gantry robot, which is what we decided on. But in essence, what it really comes down to is you can kind of get rid of the physical controls and just give visual controls to move any sort of machinery. And for example, using a crane was a good example. You have someone giving hand gestures and then someone else giving the physical controls of the crane. And in our idea, we could actually get rid of that middleman and just give hand gestures to a visual cue that would then give the crane direction. And so pretty much the full point of ours is we have the Kinect to give the visual cues, then we relay the position coordinates that we want to the Raspberry Pi through Wi-Fi, and then the Raspberry Pi then sends data to the Arduino Mega, so that we can then control the motors for the X and Y and eventual Z direction to put it in the designated position that the Kinect user put it in. There you go.
I'm going to actually demonstrate how the Kinect works and talk a little bit about its capabilities. And I would start, doing this. It looks for kind of what all the Xbox 360 games initialization looks for is a wave. Now, what the Kinect operates off of is this infrared sensors, this 3D dot mapping it makes. Now, it gives it individual XYZ coordinates it feeds back. It's this giant array of data, and then with that array of data, it performs a couple of filters and searches and looks for the hand, so on and so forth. Anyways, and then to kind of demonstrate the capabilities, you can move it in XYZ coordinates, up, down, left, right. You'll be able to send it coordinates with this block here. You can I don't even know what that block does, but it'll do something in that block. And then it will reset. I have to toggle the Z-axis. And then you can reset it. Now it's important to know here, we can still add capabilities. This block right here is kind of our dead block. It doesn't do anything in here. And with this one as well, you always have to toggle the Z right before you send the next coordinate. But the cool part about this is that there's a wide range of things you can apply this to. Actually, in my other class, I've used this same setup to control an RC car. I can move it around with just hand gestures. The next step, of course, would be to do feature gestures, but I'll leave it at that.
We have the main components are the X, Y, and Z axis. We have the X axis is where we move in the X direction here. Then we have the Y axis, and then the Z axis is the port that goes down and picks up the object. We have an emergency stop here just in case there's a finger somewhere getting pinched, or something is jammed and the motor is overturning itself. We also have obviously this is the joystick. There's X, Y, and a push button on it. We have the Arduino Mega, and we have this SparkFun quad stepper motor controller that powers the two stepper motors for the X-axis and the stepper motor for the Y-axis. We also have limit switches here, just in case it runs into the boundaries. It will prevent it from overrunning its boundaries. We have, there's another motor controller here. This is the Z-axis motor controller, and it also controls, there's an electromagnet on here that is picking up the piece of metal. We were going to use a claw to grab something, but for the sake of our budget and simplicity, we ended up using the electromagnet. We also have our Raspberry Pi right here, and we have our network device here, the wireless network router that is communicating from the Pi over to the Kinect controller, and the Raspberry Pi is communicating with the Arduino via the serial port. And there you have it. Here we also have, not only do we have our Raspberry Pi over here, but we have some actual Raspberry Pi that we're going to eat with this thing. And this is like the culmination of the final product.
Cheers.
No.
Cheers.
Clink. Not as delicious as that Raspberry Pi,
No,
but
it's still.
it's up there. Gotta say.
Very good.
Very good.
Very good.